Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from CNBC International, featuring Lila Ibrahim, COO of Google DeepMind. Her perspective on AI in education challenges the dominant narrative in three specific ways. First, that chatbots should withhold answers rather than provide them. Second, that disabilities like dyslexia reveal flaws in our measurement of intelligence, not in the students themselves. And third, that the teaching profession can only survive if AI removes administrative burden. These claims rest on a technical bet that learning itself can be treated as an optimization problem, similar to protein folding. Google DeepMind's COO, Lila Ibrahim, describes their approach to educational AI in terms that directly oppose how most people currently understand chatbot functionality. The widespread assumption treats systems like Gemini or ChatGPT as designed to deliver immediate answers. Schools worry students will bypass effort and extract final outputs without engaging in the learning process. DeepMind's engineering direction moves in the opposite direction. Their guided learning feature explicitly avoids providing direct answers. This represents a departure from the search engine model Google built its business on for 2 decades. Where previous technology aimed to minimize friction and maximize speed of information delivery, this new system deliberately reintroduces resistance. The AI operates as a Socratic tutor, guiding users through reasoning steps rather than presenting conclusions. The distinction lies in repositioning AI from an information source to a reasoning facilitator. The technology's value emerges not from what it delivers, but from what it strategically withholds. This technical choice connects to a broader claim about how we categorize cognitive ability and disability. Traditional educational systems frequently classify conditions like dyslexia as intellectual deficits. Students unable to produce clearly written essays often receive labels suggesting limited capability. Ibrahim uses her daughter's experience to dispute this framework. Her argument centers on separating intelligence from the mechanics of expression. AI functions as what she calls an accessibility multiplier. Her dyslexic daughter used AI not to fabricate work, but to translate complex internal thinking into externally comprehensible structure, eventually advancing to a communications leadership role. The claim here is that AI demonstrates intelligence and expression operate as distinct processes. By delegating expression mechanics to AI, we don't reduce human effort. We unlock cognitive potential previously inaccessible through conventional literacy requirements. DeepMind's approach to education improvement rests on treating pedagogy as an engineering discipline rather than a social practice. Education traditionally falls under the category of art or social science domains considered human-centric and resistant to precise measurement. DeepMind rejected this classification 3 years ago, choosing instead to treat learning as what Ibrahim calls a first-class science problem, equivalent to their work on protein folding or material science. The underlying assumption holds that knowledge acquisition in the human brain represents a solvable optimization challenge. They assembled teams of computational neuroscientists and child psychologists to develop their LearnLM model. The conceptual tension emerges from the claim that teaching's human element can be converted into quantifiable data. By applying hard science methodology to pedagogy, they believe individual learning curves can be optimized with the same precision used to improve server farm energy efficiency. This scientific framing leads to a counterintuitive conclusion about AI's impact on teaching jobs. The dominant concern positions AI as a job elimination technology, with teachers particularly vulnerable to software replacement. Pilot data from Northern Ireland suggests a different outcome. AI may represent the only viable path to preventing teaching profession collapse. Teachers using these tools saved an average of 10 hours weekly. The mechanism operates through task redistribution. Teaching work has accumulated layers of administrative overhead, lesson planning, grading, data management. By transferring these cognitive tasks to AI, teachers don't become redundant. They recover time for the human mentorship component of their role. AI functions here not as human replacement, but as what might be termed a time generation system that returns professionals to their core function. As Ibrahim states directly, the computer's not the magic, the teachers are. The infrastructure requirements for educational technology deployment have undergone a fundamental economic transformation. For decades, EdTech meant physical hardware investment. Ibrahim references her earlier work establishing computer labs in Lebanon requiring electrical systems, physical servers, expensive logistics, and substantial capital expenditure. The previous model demanded heavy infrastructure for education, distribution, this economic structure has collapsed. Deploying a modern large language model makes it instantly accessible globally. Distribution costs have dropped from constructing facilities to downloading applications. For anyone familiar with traditional development economics, this represents a dramatic shift. The most sophisticated educational infrastructure in human history now operates at near zero marginal distribution cost, bypassing borders, shipping constraints, and local budget limitations entirely. DeepMind's operational culture reflects a deliberate rejection of Silicon Valley's dominant velocity-focused ideology. The prevailing industry philosophy prioritizes move fast and break things, treating speed as a singular success metric. DeepMind operates under different constraints. Ibrahim disclosed that her hiring process involved 50 hours of interviews. By contemporary tech standards, this appears inefficient. The rationale, shared with Demis Hassabis, holds that when building technology capable of reshaping civilization fundamentally, deliberate pace becomes an advantage rather than a liability. They assemble interdisciplinary teams, ethicists, psychologists, philosophers before code development begins. The underlying bet suggests that in the AGI era, thorough deliberation provides superior competitive positioning compared to raw speed. They're wagering that the organisation moving carefully enough to establish proper safety parameters will ultimately prevail, contradicting 2 decades of startup conventional wisdom. Ibrahim's framework consistently treats AI not as a tool that automates existing practices, but as a forcing function that requires us to reconstruct our definitions of learning, intelligence, and human time allocation. The central question becomes, if education shifts from possessing answers to managing accessible intelligence, can our current institutional structures undergo the necessary re-engineering? If you're interested in the video featured in this episode, click the link below to watch the original.